Alright, day 4. Let's hope this one takes a little bit less time than yesterday because that took forever. Okay, so I'm just gonna skip over that story. So we are on an island. Right, we went up the gondola and now we've reached an island. Great. He's on a different island though. Okay. I'll let you borrow my boat and you can visit the garden. I've got all these scratch cards as a gift, but I can't figure out what I've won. Okay. Well, it looks very much like day 2. Okay, the elf leads you over to a pile of colourful cards. There you discover a dozen of scratch cards, all with opaque covering already scratched off. Picking one up, it looks like each card has 2 lists of numbers, separated by a vertical bar. A list of winning numbers, and then a list of numbers you have. You organise the information into a table. As far as the elf has been able to figure out, you have to figure out which of the numbers you have appear in the list of winning numbers. I mean, okay, that makes sense. The first match makes the card worth 1 point, and each match after the first doubles the point. So it's geometric sequence 1, 2, 4, 8. Okay, so we have 41, 48, 83, 83, and then we have a lot more numbers. Okay, let's see what the explanation is. In the above example, card 1 has 5 winning numbers, these ones, and 8 numbers you have. Okay, of the numbers you have, 4 of them are winning numbers. Alright, so you have 41, no, 4 of them are winning numbers. Yeah, 40, 48, 48, okay. That means it's 8 points, so 2 to the power of 4. Yep. 2 to the power of 4, no, sorry, 2 to the power of 4 minus 1 to account for the first, yeah. 1 for the first match, then doubled 3 times, okay. Card 2 has 2 winning numbers. Okay. Alright, very cool. Yeah, let's not fall for this edge case if we set winning at 1, because we then want to double each time. Okay, well, it's probably fine. So in this example, the elf's pile of scratch cards worth 13 points. Take a seat, last pile. Okay, I mean this seems fine. This seems very fine, and very doable. It looks a lot like our other day. So I think what I'm going to do is I'm going to separate by spaces and vertical. They're always 5. You always have 5 numbers. A list of numbers you have. I bet not. Let's have a quick look at. Yeah, you always have more. So I'm going to split on the vertical bar first, and then I'm going to split on spaces on both. I think. Yeah, that's better. Okay. So let's do our tokenizer from before. The vertical bar split equals. We need to import standard. Alright, let's try and do this one quickly. I do not want to repeat of yesterday. Standard.mem. What's going on? Oh, maybe is my LSP not working? Please work. Standard.mem.tokenize sequence, and we want U8 input. And this is already split on so for input line, we want to go we want to search for a vertical bar. Okay, each one's gonna have 2. We're gonna say var my nums equals dot next question mark. And then we'll say winning nums is this, and var space tokenizer. Because I want to split on spaces. We want to split on spaces. Wait, is there just wondering, standard.mem.split. There is, yes. Oh, it returns a split thing anyway, so it doesn't quite matter. So these are the numbers we have. So I think what I'll do first is I'll do the winning numbers. Which I'll do these ones first. Best I can know is a split U8. The buffer is my num. This is the other way around actually. This is winning nums and this is my nums, and we are separating on a space. Let's just leave a comment here to remind ourselves of that structure. So it's going to split this, and so we're going to do space tokenizer.next, space tokenizer.next, because we want this first, and then this, and then do we start, then we start actually, yeah. And we need to add this to a list, I suppose. An array list, because we don't really know the size. Yeah, sure, we can do that. An array list, I guess. Be a little bit lazy, but let's print some stuff. Const print equals standard.debug.print. So I'm tired of typing all that. Let's do while space tokenizer.next. Alright, let's just do this very quickly. Make sure we're doing the right thing. Num. Okay, zig. Yeah, there we go. Oh, we don't want to split on input. We want to split on line. There we go. Okay. Nope. Can you work? You cannot work. Oh. Oh, I need to do this. Underscore equals. Oh, actually, just underscore, right? I just discard it. Yeah. Take away 0. Oh, right. Okay, hold on. Yeah, because at this point we get some stuff. So we get 1, which I think is a 6. Oh wait, what am I getting here? This looks weird. My nums and my nums. Oh, wait. Winning nums, maybe? This might be more appropriate. Yeah, 41, 48, blah, blah, blah. Okay, cool. Yeah, it's going to do this a couple times. Yeah, that's all good. But I guess I have to check if num1, if the number dot length is 0. That's just num dot length is bigger than 0. Because we are getting those empty spaces, I think, from the very last split. Yeah, okay, let's keep that one there. Okay, and what I'm going to do is I'm going to make a map, I guess. At least we get 01 instead of checking an array or an array list multiple times. So I'm going to make a map for each time here. And it might come useful in part 2. Getting a sneaking suspicion of that. So var map equals standard dot hash or auto hash map, right? This is the best one. So the key the key is e32 and the value is let's say U32, just in case for part 2 this is useful. So what we say is each time here, we're going to say map.put. We're going to do try standard.fmt.parseInt, and we're going to try U32. We're going to pass the num and base 10. So that's the key. And what we want to pass is, like, let's say 1. Why not? We're going to do that, and after we're done, after we are done, we go while my nums dot, oh, we need a, can we reassign space tokenizer equals standard.mem dot split u8 on my nums and a space there, and basically we're going to copy this code here. We're going to copy this code. So synchronize num. Okay, if num's bigger than length, what we're going to do is we're going to do var num var winning num equals this following num. We're going to say if not map dot if map dot has no dot map dot I guess let's say get then map dot get the winning num. We can discard the capture there if there is one. Is there really not like a has map dot get put init move count? I guess we can do counts. That seems so weird to me. Counts of the winning number dot, what does count even return? What is this count? Count, what size? Size is u32, okay. Oh, right. If it is equal to 1, actually not equal to 1. Yeah, let's, equal to 1, because that's what we set it to. Then let's set var part1 equals 0, and let's make you a u32. And var current score u32 equals 0. Okay. Now we want to go up to 1. So we're going to do current score plus or equals standard dot math. We're going to do 2 to the power of the current winning score. Yeah, great. Pow 2, no, pow u32 2 and current score. Yeah, that means we don't have to do any other things, and we're going to do part1 plus or equal current score. Print part1 Let's see what we have. Oh, what's that? Auto hash map returns a type. But if I set it to a const, this won't work, right? Okay, maybe. Or is it because map itself is a type? Set it to const, but then I don't know if the put is going to work. Okay, well let's continue. Put expect 3 arguments. Oh yeah, no, it needs to be a var, and I think map slash my map instead. I think for some reason is map reserved maybe. No, try. Wait, init. We need to init. Yeah, oh god, I'm silly. Var. Let's do const allocator equals standard.mem dot page dot heap dot page allocator my map dot init allocator, and then we're going to defer my map dot actually let's just do it at the end of the loop right here. My map dot d init. Right, nice and tidy garbage collection there. My god, what is going on? Alright, let's zig learn quickly. Map. No. Map. Hash maps. That's it. Okay. Dot init allocator. Yeah, that's it. Error is ignored. Yeah, correct. Member function expected 0. Oh. Dot get. Okay. Let's do that. Did we get it? Oh no, we did not get it. So the thing is, let's just do it for one. Let's do print found none. Just to see what is going on. Doing none. Found num 83, 86, 17, 48. Is it 4 for that first one? 41, 40. So yeah, we have 83, 86, 31 no, 17 yes, 9 no, 48 yes. 1, 2, 3, 4. What? Card 1 has 5 winning numbers and 8 numbers. Oh, yeah, that's correct. Cool. Worth 8 points, and we get a really big card 0. That's interesting. So if the current score is 0, current score plus or equal 2 to the power of the current score. 2 to the power of 0 is 1. And then 2 to the power of 1 is 2. Plus, what? What am I doing wrong? Why am I getting such a big number? What? Oh, come on, man. Am I messing up powers? Okay, alright, like, we have to figure this out. We're gonna figure this out. I didn't want to go down this rabbit hole. But am I just very silly? 1, 2, 8. Okay. So, so 1 to 8 is going to do current score plus or equal to 1, and then true, and then 8. Oh, and then 2, 0, 4, 8. Yeah, okay. Oh, it's not quite. It's not the number. Oh god, yeah, I am messing up powers, I guess. Yeah. Silly, 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 silly. Okay. So I'm just gonna say if current score is equal to 0, then current score equal 1. Else, I mean, we could continue there. Current score plus or equal to current score. So if it's 1, it adds. Why am I just messing this part up so much? No, it doubles. 1 doubles to 2, which then doubles to, yeah, that's probably fine, right? Oh, okay, there we go. Trying to be fancy and I get a bit for it. Okay, 13. Okay. Invalid character? Interesting. Where? I get invalid character on... Huh. Oh, is it like a space here or something? 2, 3. I mean, we got a lot of spaces there, actually. That's a bit strange, isn't it? Invalid character. Yeah, because the example is quite a bit different. So it might be the case that, yeah, it's like breaking here. So let's print num. Yeah, there's like a lot more spaces in the real puzzle than there is here. Num1. Yeah, look at that. Oh, sorry. Alright, let's do split sequence. See if that helps. No, it does not help. Ugh. Yeah, because of all those spaces. What? Let's do instead of a split, let's do a tokenize sequence. So hopefully it will just ignore the extra spaces. Tokenize sequence. Interesting. Okay, so yeah, split doesn't ignore extra spaces. This seems to do. Let's tidy up you and run. Okay. That should be part 1. Great, let's go. This is you're about to report your findings to the elf. One of you realize the rules have actually been printed on the back. There's no such thing as points. Instead, scratch cards only cause you to win more scratch cards equal to the number of winning numbers you have. Especially, you win copies of the scratch card below the winning. Oh, right. Okay. Okay. Copies of the scratch cards below the winning card equal to the number of matches. So if card 10 were to have 5 matching numbers, you can win a copy each from 11, 12, 13, 14, and 15. Copies of scratch card are scored like normal scratch cards, and you have the same card number as the card they copy. Okay, right, interesting. So if you win a copy of card 10 and it's 5 matching numbers, it would then win a copy of the same. This process repeats until none of the copies cause you to win. Cards will never make you copy a card past the end of the table. Okay, that's useful. No need for modulus operators there. Okay, so card 1 has 4 matching numbers, so you get, so you win a copy of the next one. The original card 2 has 2 matching numbers, so you win 3 and 4. Your copy of card 2 also wins. You, okay, your one instance of card 6 has no matching numbers. Huh. So once they've all been processed, you end up with 1 instance of card 1. 2 instances of card 2, 4 instances of card 3, 8 instances of card 4, 14. So I'm already thinking that this is going to be kind of a caching problem because it's going to happen so many times. So what I'm going to do is we're going to make a hash map of the... Oh, no, we run through each one. So we're going to make... Okay, we're going to run through each game. We're going to calculate the winnings. We're going to store those in the map, and we can always consult back. So, first of all, we need some sort of... Right, this is very interesting. Okay, let's just start coding. First of all, I'm going to need dot there. I'm going to need an index, okay. And just because I need this one as well, the tokenize sequence, tokenize any? I think it's tokenize any, no, because I need the column to be, yeah, tokenize any. Great. Okay, so now that gets rid of that colon there. Okay, we're gonna run through each one, and so I mean we're gonna keep part one the same. Okay. Now we're gonna say. Now we do want to say numbers 1. If there is a winning number, so numbers 1 plus or equal 1. Great. Well, I think actually we leave this list this for part 1, right? We leave that just kind of intact. And we don't mess it much more. So I'm gonna take this, go right to the end, and I'm going to print this here. All right, so what do we need? We need an index. We need to split some stuff. We need to split some stuff. We need to tokenize some stuff. But then we're gonna need. Okay, so I'm thinking the first go of the loop, we just insert into a map of games that need processing. Okay, so we go games that need processing until they're all done. So yeah, okay. Var processing games processing equals standard.auto hash map. This is going to be U32 for the actually it's going to be U size for the index of the number, and it's going to be U32 because of the number of things we might need. So we need allocator and defer games processing dot d init. Perfect. So yep. Cool. So here we don't do this. We do var numbers 1 plus or equal 1. We don't do this. We don't do this. Do we need my map? Oh yeah, we do need my map, I guess, to find this. Yep, this stuff. So now what we're going to do is we're going to see the number of numbers 1. Ooh, so it's going to be yeah, so for 1 dot numbers 1 plus 1 I. So if numbers 1 equals, let's say 4, this is going to go 1, 2, 3, 4, and leave it there because it's non-inclusive, as we painfully found out yesterday. And and now we're going to do insert into our games processing. Oh no, I said I wasn't going to do this, was I? Oh, I mean, no, we need to run it once, I suppose. We need to run it once. Oh, but it would be a lot nicer if we split these up, wouldn't it? So we run through them. So like we need to process. Yeah, we need to. Okay. For input 0, line index. We're just gonna say games processing dot puts. I'm gonna put the index of it, and we're gonna say 1. And we're gonna need to, yeah, that's it. We're gonna need to process. We're gonna need to process each game, once. Yes. So now here, what we do is we say. Basically, we want to run through this games processing. So games processing dot iterator key iterator, value iterator. Yeah, we probably do want to do that, don't we? Iterate. I'm just not sure what it outputs. An entry. Okay, that's fine. So while games processing dot iterator dot next entry, right? Entry dot key points. Yeah. So this is going to be the game index. This is going to be num of games value pointer. Okay. And basically, oh, but this might not always work. I think we could probably do. We want to go until it is truly empty, but the iterator might, because we're going to mutate it as we go along, so it might not always do the right thing. So we would need like another loop above it to kind of just keep going until we break. So, but okay, you know, one thing at a time. Let's take this same thing, this same logic, and we're going to say the line is equal to the input at game index. Game index, winning numbers, current score. Current score we don't really care for. Yep. We don't need this one. So, no, we do need that actually. Games 1. Here what we're going to do is we're going to say games processing dot put. We're going to put the key, which is the index, we're going to put I. We're going to put 1, right? It entitles you to 1 more of that game. But yeah, this is when the iterator would then become kind of, you know, false. So we're going to need a while true. Oh no. Yeah. There's probably a smarter way of doing it. Basically, what I'm going to do is I'm going to do a while true, and every time we exit this first loop, I'm going to fold some of this code away. So there we go. Every time we exit this first loop, we're going to say while games processing dot iterator. We're going to do value iterator dot next. If val is bigger than 0, then we're going to what we're going to do is basically continue up here. Find any excuse to use labels on loops here. Break to out loop. Otherwise, if we reach this, then we are going to break fully out of that. So, okay, yep, and then we need to keep some sort of score. Once all the original copies have been processed, you end up with 1 instance of game 1, 2 instances of card 2, 4 instances, 8 instances, 14 instances, 1 instance. In total, this example pile of scratch card causes you ultimately to have 30 scratch card. Processing all the original copies until there's no more. How many total scratch cards do you end up with? Okay. For part 2, either do 0, so part 2 plus or equal 1 here. And each time we put something in here, part 2 plus or equal 1. Just like imagine if it ran first time would be great, wouldn't it? Okay, What's complaining about? Expected hash map found const. You did you? Where? You found this on against processing it straight to next. Here. Why not? Why can't you iterate? Creates an iterator over the instance map. The iterator is invalidated if the map is modified. I mean, that makes sense. Expected type. So it's saying that we found a const. Var iter equals games pressing dot iterator. Maybe that. You know. Value iterator. What about this? Wait, what is the difference here? Oh, val iter. Is that it? No. Oh, val dot pointer, yeah. And we need to actually print part 2. 15 is not right. Okay, so card 1 has 4 matching numbers. I think it's because we don't run through them that much. We do like next entry. So we win the game, but depending on how many we have, numbers 1, depending on how many we have, right? Oh, we could do plus or equal 1 num of games plus or equal to num of games. That still gives me 15. Just gonna run once. Oh, we're not gonna break. We're gonna continue on the outer loop. Okay, we get an infinite condition there. We're going to continue on the outer loop. Okay, and it's going to come back down. Okay. Let's just, instead of continuing here, we're just going to print val, I guess. Logic is wrong somewhere, I guess. Yep. Okay. 1 1 1 1. But we're going to. Oh, first of all, we're going to put num of games here. Wait, are we? Yes, we are. Pretty sure. So game 1. So the game is the game index, numbers 1. So game 1 1 2 0. That can't be right. Game 1 1 4. Oh, off by 1. Let's do game index plus 1. Right, because the index here in this case starts at 1. That still doesn't look right. So for game 2, 1, 2. So game index. Now let's keep the index like correct, and only here let's do +1. And I think this is fine. I think maybe it was all okay. Okay, run. Game 1, 1, 4. Okay, correct. Game 2, 1, 2. Yeah, okay, so we run through all of these. And we add the number of, so 2 plus 4 is 6. 9. 9 plus the initial 6, yeah, 15. Okay, come on. What am I doing? Into the games 1, and we're going to put into games processing I, which starts at 1. Oh, it's the next. So it needs to be, starts at game index, wherever I am, +2, right? If I am game 1, I need to add game 2, so I need to say, so game 1 index is actually 0, so from 0 to reach 2, we need, yeah, this 2, and then, yeah, okay, so I'm also going to print adding space I. Okay. Numbers one integer overflows. That doesn't seem right. That does not. Is it? That doesn't seem right. If numbers 1 is equal to 0, continue. Okay, that helped, but didn't quite do it. So game 2, 1, 2. Yep. Game 1, 1, 4. Adding 2, 3, 4. Let's print some prettier stuff. So, funny enough, game 2, that 1, 2 didn't add anything. Oh, right, because this has to be game index +2 plus, you know, it has to stay in line there. So number 2, adding 3 and 4 and 5. Okay, so let's get rid of this extra one here. Okay, game 2, adding actually we want this up here so it doesn't conflict. Okay, adding 3 and 4. Game 1, adding 2, 3, 4, and 5. Game 5, game 6 didn't win anything. Game 3, 1, adding 4 and 5. Okay, so I think this all actually looks fairly correct. And the number of games is basically always going to be 1, and then we're going to go here. And we're going to take a look at the value. We're going to do games processing.value iterator after doing a bunch of puts. So 3, and then number of numbers. Number of numbers is number of games even 1. Oh, we need to increment. Oh god, we need to increment. For current nums equal. Try games processing dots get num get I, and that's always going to be defined. So we're going to do current nums plus or equal to num of games. Expected error union type. Oh, get doesn't do it, does it? So we're going to do plus or equal. What we're going to do is we're going to continue on the outer loop up there. Outer loop. If we find, oh, but we're not decreasing this anywhere. Right, we go through the entry and we add, and at the very bottom we need to go try game, because we've processed them all, dot puts, dot set, I think it's just put, yeah. Set on the game index where we are, we're going to set it to 0. Because we're done with those. We're going to continue until we are fully done. Okay, infinite loop, so that's not great. So let's get rid of you. Let's get rid of you. So, let's do iterator here. Entry val equals entry dot value pointer var key equals entry dot key pointer dot star key key. Yeah. So after we went through those, game 2 1 2, so added 3 4. Game 1 added 2 3 4 5. Game 5 didn't do anything. Game 6 didn't win anything. Game 3 1 2 added 4 5. Okay, so we went through 2 1 5 6 3. Done. Game 4 also we went through those now. We added that. We have a key 4 and 5, which is 5 and 7. Okay. I mean, it's a bit annoying that we can't quite get this. So after the first time, we're going to have quite a few game 4s. Is this correct? Okay. So let's just check if that is correct. Because if it is correct, I've got to get the notebook out for this. I guess so. We're gonna have 1 2 3 4 5 6. So we're gonna have 1 3 and 1 4. We're gonna have 2 3 4 and 5. Game 5 did nothing. 6 did nothing. 3 added a 4 and a 5. Game 4 1. So we're gonna add a 5. Yep. Gonna add a 5. Okay. So actually maybe mutating the map in place isn't the best, because we probably get tripped up a lot. So I'm gonna change that. So I'm gonna change it so we have we do iterate through games processing, but each time we're gonna free games processing and we're gonna do something else. So that should become easier after that. So this here should be setting in our new thing. So we're gonna say var new games processing equals standard.auto hash map. It is view size u32, and we're going to init with an allocator. And in here, we are going to check these iterator values, but instead, after we've won, we're going to add, not into games processing, but into new games processing. Yeah. So now, yeah, this should be a lot easier to follow, because we do new games processing here, and here we can do games processing dot d init. So make sure that it really does go away. We get rid of that there. All right, should be a little bit easier to follow. Okay, so then we're gonna go through each one. So key 5, 4, 2, 3. Yeah, we didn't have any game 1. So it says that we have a 5. We have a value of 2 there. 4, 2. Is that correct? That doesn't seem right. That cannot be right. So game 2, we're adding a 3 and a 4. Yeah, we only ever added 2 once. Oh, try games processing, put game index 0. Let's get rid of you. So we want this to be very clean. Yeah, we still want to increase, I suppose. Do we want to increase? Or do we just want to say current nums? Because we're going to go through all of them. Let's delete that and just check. Not current nums. This is what needs to be deleted. But now this looks quite wrong. Yeah, that looks quite wrong. Let's actually do new games processing dot get plus current nums there. Okay, the current nums equals 0. We're going to do if, and we're going to capture the n from there, current nums equals n. Okay, this looks better. So game 2 added 3, 4, 2, 3, 4, 5. So 3 should be 2. 3 is 2. 2 should be 1. 2 is 1. 4, 4, 4 should be 3, and then 5, 5, 5, 5. Perfect. Okay, great. So then what we do is we iterate over, and we see that, okay, some of them are not quite right. Some of them are not quite right, so they're bigger than 0. And what we do here is actually we say, okay, games processing, you are now going to be equal to new games processing. And then it's going to go back up. It's going to do that. It's going to take the iterator. I get 19. Okay. I get 19, that's not right. I get 19. Tell you what, let's print all of these, and let's continue here. What's the time? God, I should have to get going in a bit, so I might have to come back for after lunch. But has values equals false, has values equals true. We're going to break out of this loop. if has values continue. So now we should be able to just print. Oh no. Yeah, let's remove the break so it's a bit easier, I suppose. And then we're going to print just that stuff. Okay. After the first time, we have 3 5s, so 1, 2, 3, 3 4s, 1, 2, 3, 1, 2, and then 2 3s. Okay. Next up, we go through the game iterator. So this is the next time. We have no game 6s. No, I mean we do have game 6s, but now we don't. So we only added game 3 1, so we added 4 and 5. Game 4 1, and we had 3 of those, so we're going to add a lot of 5s. Add a lot of 5s. And then it prints. Wait, it didn't. What about the 2? Oh, we added 2. Where'd that go? Where did the 2 go? Okay, well, I'm actually going to have to go and start work now. But I'll come back in just a second to finish this, probably around lunchtime. Yeah. Right, we are back. It is lunchtime now. So, part 2, where did I leave off? Okay. Just reading the instructions here. It says your original card 2 has 2 matching numbers. So you win 1 copy each, and then your copy of card 2 also wins. Okay, I mean they seem to have done it in a slightly different way. I suppose like they are mutating as they go along, which was my first approach, but it doesn't seem that great, I suppose. Well, maybe it is. I mean, I don't know. It seems strange. Maybe what we could do is go through, instead of going through an iterator, we go through 1 to the very last number, which should be input length. Yeah, input length, 1 to input length, plus 1, and kind of check like that, and then we can keep mutating the exact same map. I'm gonna try that. Might be wrong, might not work, but let's try that. So basically, we still want this. We have a map here, we have a game, yeah, the iterator, we put 1 on each. Okay. Let's add, okay. And then here is where I think maybe we could do something better, right? So I think we can have a while true here. We go through the game. We go through the game through each one, but I don't think we go through iter.next. Right? What we go through is 1 dot dot. Go through 1 dot dot input dot length. So if it has 5 game, we want to go plus 1 here. 1 dot dot. Oh, 4. We don't want the iterator. We want to go through, and this is going to be our game index. So we can change these. Game index. We want to take away 1 for this. Okay. And the thing is, at the very top, what we want to do is if games processing dot gets, if we get the game index, right, forget the game index. And there should always be one of these. Right, oh, no, either way. If I, and I in this case is, yep, that type. If I is bigger, if I is equal to 0, we continue around the loop. And we have a variable here, games played, which is equal to false. But as soon as we go here, we go games played equals true. Right, so then that's our condition at the end. If not games played, we break out of that, of the while loop. Okay, so games have been played. Okay, we come here, we go, right, very cool, we are playing a game. And yep, so this is all the logic to, yep, and then we go here and we need to increase our number of games here, we need to get that. Var num of games is equal to games processing dot get. We do a get up here. Games played equals games processing dot get game index, and here we do games played if I, yep. And then down here, games played. Here we do games processing. Games processing. What's going on? Games played. Local variable shadows. Oh, num of games. Num of games. Yeah, we don't need that. And we're going to put num of games, and I think this could be. I think we probably need this. I think. All right. I think the LSP wasn't behaving. Let's just see what happens. Yeah, I thought so. No field games played. Oh, wait. And the LSP is just okay with me doing this. Games processing. Yeah, the LSP really isn't being much help right now. Okay, I mean, it seems to overflow, but that's just fine. That just means our logic is somewhere else, so I think let's just break. Yeah, let's just break straight away. We break straight away. Let's comment this out, and we break straight away. Here we're gonna see, I want to see what the games played are. So game num, no, actually just game num of games, then a new line. So the game is game index and num of games. So we should see question mark there. There we go. Alright, so I think we already have something a little bit wrong, right? Because there is game one, but if you remember, game one should add another game two, so that isn't being added. So here, we should be doing that adding logic. So games processing dot put there, you know. This seems a little bit wrong, so let's just print adding and then all of these, and print, and you go after, you go here, and we're just going to print I. Okay, So we're adding, let's do a comma, space. Alright, so adding 3, 4, 5, and 6, that's wrong. So we need to go +1 here. Okay, 2, 3, 4, 5. 2, 3, 4, 5. Game 5. There are 14 game 5s. Is that right? 14 instances of game 5. Alright, we're on the right track. But then it says what? Num of games. But numbers 1. Oh. Game 5 can win something? Does game 5 win? Your 8 instances of card 4. No. Your 14 instances of card 5 on original 13 copies have no matching numbers. So numbers 1 should then be 0. Right? Print numbers 1. I'm confused. That should be 0. Okay, so it continues, right? Right. But it doesn't. Is it what? Yeah, question mark? Oh, really confused. Do I misunderstand how continue works? No. Because yeah, we're printing up there. Num of games. Ooh. Question mark there. Is that what was wrong? That was funny. It was an error in our print. Let's just comment some of this stuff out, just in case we need it later. God, I'm taking too long to do this already. So let's not break. And let's do that instead. Integer overflow. That's fine. That's great. The first time it went, it was fine. Like if we braked. Okay, we don't break. You go back up, and the integer overflows. Integer overflows. Let's get the print statements back. If nothing has been played, then we go here. Okay. This goes on for a while. Oh. Else continue. I still gets it wrong. Sleep. If none of games. Let's just do an unreachable there, just in case. We set it to true. Kind of does the whole loop and then goes back up. Does it reach it? Yeah, it does reach it. So yeah, I guess game 6. Otherwise, we just continue around the loop. Yeah. The thing is that now I need to you know, I need to go all the way to the top on here. But it's gonna cut out, right? I'm not gonna have enough of the standard out there. Okay. Let's just keep a counter, I guess. Our count is equal to 0. Let's keep you at usize. Last counter is smaller than 5. Counter plus or equal 1. So, there we go. Game one twice. We're not decreasing. Each time we go around the loop, we are not decreasing. We're not decreasing the current one. Oh, yeah, I should have thought about that actually. Put I, which is the game index, just to where you define there, so that's correct. Num of games -1. Optional. There you go. That should never. So it does. Game 1 num of games. Heading 5. Num of games. Oh no, we should set this to 0, right? Because we are processing them like in a batch. So yeah, you go down to 0. Okay. I think we might be onto something. A lot of edge cases, man. I'm really off with these edge cases. So 30. Okay. Well, I think we've done it quite an efficient way. Like that. Okay, that ran instantly, so no need for that. Like the fact that we did it like this. Let's see. Oh, let's go. Okay, efficiency. That was basically instant. Really cool. It took a little bit longer than I thought it would, but anyways, it got there in the end, and that was much more enjoyable than yesterday. And I did have to stop because I ran out of time in the morning. Anyways, thanks so much for watching, and I'll see you tomorrow.